Let's get some more practice with our conversions and also figuring out what the range of valid IP addresses and the broadcast address is for a given subnet. And here the subnet that has been given is 222.23.48.64/26. So let's get in a little practice with our conversions. We know those first two bits total 192. We subtract 192 from 222, leaves us 30. Can't subtract 32 from 30, but you can subtract 16, that leaves us 14. We can subtract 8, leaves us 6. We can subtract 4, leaves us 2. We can subtract 2, leaves us nothing. And that's it. 23. We know we're going to start that with some zeros. We can put 1 under 16. That leaves us 7. 23 minus 7. 23 minus 16 being 7. And then the 4 and the 2 and the 1 add up to 7. So we've got a total there of 23. 48. We know that's going to be the 32-bit and the 16-bit. And we'll go ahead and finish breaking it down here. 64, we'll finish that up. And that's it. So there's our binary string. Let me string down a bit here and type that out. Ooh, it's always a little bigger. That's okay. And there's our binary string. So now we just need to look at the address and say where are the host bits and what would the result be first off if they were all zeros. Well, that's the way this one is anyway. There's your all zeros address. So we know what that is. That is 222.23.48.64/26. Now though, where are the host bits and what would this value be if they were all set to 1? Well, 32 minus 26 is 6. The last 6 bits are your host bits. And if those are set to 1, 1, 2, 3, 4, 5, 6, then what do we have as a result? And keeping in mind this is your broadcast network. Your broadcast address. What is this value? It's 127. We know that just by looking at it at this point. So we have a subnet address of 222.23.48.64, and we have a broadcast address of 222.23.48.127. Everything between that, which in this case would be 222.23.48.65 through 126, those are your valid IP addresses. And that's all there is to it. Let's go ahead and erase here. I'll bring those fonts up when we can. We'll erase this. And our next example is going to be 140.10.10.0/23. So a quick conversion here then, because 140 minus 128 is going to be 12. We can't take 64 or 32 or 16 out of 12, but we can take 8. That leaves us 4. So our 2 and our 1 will be 0. Checking my math, that's 12 plus 128 is 140. 10 and then we just do it again. And then 0, I think we've got that one down pretty well. So we know that 140.10.10.23 is our subnet number, or subnet address. 140.10.10.0/23. But going ahead and putting this string into binary, so I'm going to bring that down. Not far. So we've already figured out what the subnet address is because they gave that to us. So now, what is the broadcast address? Well, the broadcast address is the address with all ones for all the host bits. And how many host bits do we have? 9. 32 minus 23. So the last 9 bits are your host bits. So if those are all set to 1, what is the resulting value? Well, we know the first two, 140 and 10, are going to be the same. But what's that last one? That last one's 11. That's 8, 2, and 1. And then, of course, the last octet, 255. So everything in the middle is a valid IP address. So your range of valid IP addresses is 140, 10, 10, 1 through 140, 10, 11, 254/23. Let's do another one here. 10. Okay, well, that's not a cheat. We'll go with that. It's another 10. Sorry about that. That's what I meant about the cheat. So let's go with 10/200/17. That sounds like a pretty big range of addresses to me. So let's go ahead and delete that. And 10, we definitely have that one down. We have the 8-bit set and the 2-bit set. And 200, what's 200 minus 128? 72. 72 minus 64 is going to leave us 8. So I know the 32s and 16s are going to be zeros. 8 minus 8 is 0. Always has been, always will be. And there you have 200 broken down. And we don't even need to put the third and fourth ones because they're all zeros anyway. So let's go ahead and put in that string 0000, and I'll bring it up in a second. 1010. Sorry about that. 11001000. And there we go. So let's bring that down in size just a bit. And let's see what we got there. Sorry about that extra movement. So if all of the host bits are 1s in this case, what do we end up with? Well, we got a mask of /17, so we still have 15 host bits. The last 15 bits of this address are your host bits. So if they're all 1s, there's the result. What is the address? It is 10/200/127/255/17. So everything in the middle is a valid IP address. So our range of valid IP addresses is 10/200/0.1 through 10/200/127/254. Let's do one more. Let's go ahead and erase those. Let's do one with a number in every octet. We're going to do 198, 27, 35, 128/27. Holy cow, I got a lot going on here. So we know that 128 and 64 are 192. I'm getting you used to doing that all at one time. So 198 minus 192 leaves us 6. So we're going to go all the way down to 4. 6 minus 4 is 2. 2 minus 2 is 0. So that means we have a 0 for everything else. 27, we know we cannot subtract 128, 64, or 32 from 27, but we can subtract 16. So we do that, and then you have a remainder of 11. 11 minus 8 is 3. You cannot subtract 4 from 3, but you can subtract 2, which leaves you 1. Whew. Worked out just fine. 35, we can't do 128 or 64, but we can subtract 32 from 35. That leaves 3. Can't subtract 16 from 3, can't do 8 from 3, can't do 4 from 3, but we can't do 2 from 3, which leaves 1, and we just made it again. 128, that's pretty darn easy. 128 minus 128 is 0. So there's our binary string, and we end up with, move that up just a tad so I don't transpose anything here, 1100, 0110, 0001111. 001, 00011, 1, 2, 3, 4, 5, 6, 7. I bring it down in size there. I like to leave the rest of it as large as I can, though. So there is our string, and we know that that's 198, 27, 35, 128. That's our subnet address, but what's our broadcast address? And you're saying, Chris, if you stop moving that, I could do it. So how many host bits do we have? We have 5. That's old hat for us already. Those last 5 bits, 32 minus 27 is 5. So you got 5 bits right there. If you set those to 1, what is the resulting address? And this is where I tell you again, be careful, although I'm sure you're nailing this by now, because some people will just concentrate on those 5 bits and add them up, and of course it's 31 because it's every bit after 32. It's 16, 8, 4, 2, and 1. Total is 31, and they'll say, okay, well the last octet is 31. Well, if your subnet address is 198.27.35.128, your broadcast address cannot possibly be 198.27.35.31. You're reinventing networking if you do that. Remember that you're taking in the entire octet, not just the host bits. You're going to set the host bits to 1, but if any of these bits were already set to 1, you got to include those. So you end up with 198.27.35. What? 159, I believe. Yep, because you've got your 16 through 1 bit set here. So that's, let's add it up right there. We got 16, 8, 4, 2, 1. The last 5 bits all set to 1. That's 24, 28, 30, 31. And you add that to the 128 bit that was already set, and you are gold. So your subnet address is 198.27.35.128. Your broadcast address is 198.27.35.159/27, and every address in the middle, 198.27.35.129 through 158, is a valid IP address. Just that simple. On that last one, you were probably way ahead of me even doing it on the board, because of course I'm explaining at the same time. But you can see as you get more practice with this, it all becomes crystal clear. And I know you can do it. I know you're doing it now. In the next section, we're actually going to have some stated design requirements, as I call them. We are actually the ones doing the subnetting this time. And of course, our bosses, supervisors, or whoever's telling us what we got to do, sometimes they know what they're telling us and sometimes they don't. But we still have to meet their requirements, and we have to know what mask is going to do that. So we will practice that valuable real-world skill in the next video. See you there.